In just 10 days, humanity stands on the cusp of a discovery unlike any other, a moment so rare that it could change the way we view the universe itself. March 18, 2026 marks a significant event, the final high-velocity traversal of the interstellar anomaly known as 3IATLAS. This is not just another cosmic object passing through our solar system. 3IATLAS is a relic, a fragment from a star system so ancient, its origins stretch back farther than our own Sunday. For billions of years, it has drifted through the void, carrying with it the chemical fingerprints of a time before our planet even existed. But why should we care about this cosmic wanderer? The answer lies in the profound implications of its arrival. This object, whose structure and chemical makeup have been locked in a time capsule of space, carries the blueprint of a pre-solar epoch. The data we collect from it is not just an observation of an object passing through our solar system. It is a chance to conduct a forensic audit of an object whose chemical structure has been preserved since before Earth was born. The very molecules trapped inside this interstellar visitor may hold the secrets of a star system that formed long before the sun ignited and our own solar system came to be. 3IATLAS is not just a comet or asteroid. It's a message from deep space, a fragment of another world, untouched by the processes that shaped our own. And yet, it is now entering our cosmic neighborhood. We're not merely observing an object traveling through the vacuum of space. We are witnessing the final act of a cosmic drama that has been unfolding for billions of years, a fleeting moment in which we get a chance to read the first and last pages of a story that has remained unread by the human eye until now. As this object approaches, it passes through our solar system with a precision that defies conventional expectations. Its trajectory, which spans billions of years, is now focused on one final encounter, the approach to Jupiter, the largest planet in our solar system. There, 3IATLAS will experience a gravitational assist, a deflection caused by the immense gravity of Jupiter. This is where the event becomes truly extraordinary. Because of Jupiter's immense mass, its gravity will warp space-time itself, altering the trajectory of this interstellar traveler in ways we are only beginning to understand. But this is not just about the physics of gravity. This is a meeting of cosmic giants, 3IATLAS, a relic from a distant star system passing through the realm of Jupiter, a massive planet whose gravitational pull influences the orbits of nearby bodies. And this encounter, this final approach, will allow us to glean new insights not just about this specific object, but about the very forces that shape our universe. What we will learn from this encounter could be monumental. This is an object that has been isolated from the universe's noise for eons, and now, for the first time, we have the tools to study it in detail. As 3IATLAS passes within 53 million kilometers of Jupiter, a relatively close vantage point, it will provide a chance for instruments that have been observing the skies for years to finally get a clear, undistorted look at this object. The science being done here is unparalleled, as astronomers, physicists, and planetary scientists work together to uncover the mysteries hidden in its structure and composition. The implications of this event go beyond simply discovering new data. For scientists, this is a once-in-a-lifetime opportunity to study a piece of the universe that carries with it the story of a star system long gone, a star system that may have never formed in the way our own did. What's even more extraordinary is that this interstellar object is not alone. It is accompanied by a long history of data, already recorded by spacecraft like JUICE and Juno, which have mapped Jupiter's magnetosphere and auroral displays. These instruments are now preparing to witness a cosmic event that could forever alter our understanding of the forces that govern the solar system and perhaps the universe itself. Yet, there's a catch. This moment is fleeting. As March 18th approaches, 3IATLAS will pass beyond Jupiter's reach, and the window of observation will close. After that, the object will continue its journey into the depths of space, heading toward the outer reaches of the solar system. Once it's gone, there will be no turning back. We will never again have the opportunity to study it up close. The data collected from this encounter will become part of the scientific record, a final chapter in a story that few could have predicted. This is the final approach of 3IATLAS, and it is more than just an event in space. It is the closing of a cosmic gate, a fleeting opportunity to witness the intersection of physics, chemistry, and the unknown. As we stand on the edge of this discovery, we can't help but wonder, what secrets does 3IATLAS hold, and how will they change our understanding of the universe? With just 10 days left, the clock is ticking. As 3IATLAS approaches Jupiter, the gravitational dynamics at play will create an unprecedented opportunity for observation. On March 16, 2026, the object will be within 53 million kilometers of Jupiter, the gas giant, with a gravitational field 318 times stronger than Earth's. This vast field will warp space-time itself, creating an interaction that will influence the trajectory of 3IATLAS in ways that challenge our understanding of cosmic mechanics. For context, gravitational assists, or hyperbolic deflections, are well-known phenomena in orbital mechanics. When a spacecraft approaches a massive planet, like Jupiter, it is accelerated by the planet's gravitational pull, slingshotting it toward a new trajectory. This allows the spacecraft to conserve fuel and gain speed, but the same principle applies to 3IATLAS as it moves through the solar system. It will pass so close to Jupiter that the planet's gravity will alter its path, speeding up the object on its journey out of the solar system. This gravitational assist will be critical in determining the final velocity of 3IATLAS as it continues its interstellar journey. What makes this encounter even more significant is the presence of the Juno spacecraft, which has been studying Jupiter's magnetosphere and auroral displays since 2016. Juno is uniquely positioned to observe this celestial encounter from an extremely close vantage point. Scientists have speculated that the spacecraft's remaining fuel and complex suite of instruments could potentially be redirected to study the passing 3IATLAS. While official channels remain silent on a potential mission redirection, the mere possibility of redirecting Juno's focus offers an unprecedented tactical advantage. This is a moment where space exploration could intersect with real-time observational opportunities, providing us with data that will deepen our understanding of the forces at play in the far reaches of our solar system. We are witnessing a convergence of data and instruments that could unlock many secrets about the object's composition, trajectory, and the forces acting upon it. Theoretical frameworks like string theory suggest that the universe operates on a principle of resonance, an interaction between objects that can echo through space-time. As 3IATLAS reaches its closest approach to Jupiter, it becomes an example of such resonance, where two cosmic entities, the comet and the planet, will interact in a way that produces new scientific insights. This cosmic symphony is unfolding right before our eyes, with the data waiting to be revealed. The convergence of these observations, made possible by Juno and other spacecraft, could offer clues that will reshape our understanding of physics. As 3IATLAS draws closer to Jupiter, two key spacecraft, JUICE and Juno, will play pivotal roles in capturing crucial data. These spacecraft have been meticulously mapping Jupiter's atmosphere, magnetosphere, and moons for years, and now they are poised to witness an interstellar object pass through the planet's realm. Their instruments include spectrometers, particle detectors, and ultraviolet detectors, are designed to probe the environment of Jupiter and any objects that venture too close. In November 2025, JUICE's 5 sophisticated instruments captured the heart of 3IATLAS as it passed through Jupiter's vicinity. However, this data was initially shielded from Earth by the Sun's massive interference. The signals only reached our deep space networks in late February 2026, and the results are expected to be released in full at the end of March. The timing of this release is critical. By the time these results are published, 3IATLAS will have exited the Jovian system and begun its high-velocity journey out of the solar system. For scientists, this is the last chance to analyze the object in detail before it vanishes into the deep void of space. The most exciting aspect of this data is the opportunity to analyze the object's chemistry as it accelerates beyond our reach. As 3IATLAS approaches Jupiter, the planet's magnetic field will interact with the comet's path, likely causing subtle shifts in its trajectory. The gravitational assist from Jupiter will increase the object's velocity as it exits the solar system, but it will also provide a new vantage point for studying the comet's chemical composition. Instruments like JUICE's spectrometers will offer crucial insights into the molecular makeup of this interstellar visitor, revealing clues about its parent star system and the processes that shaped it. The combination of data from JUICE and Juno, along with the increasing proximity to Jupiter, will create a unique window of opportunity. The release of these results at the end of March will mark the end of a chapter in our study of 3IATLAS, just as the object accelerates into the farthest reaches of our solar system. Once this window closes, the object will be gone, and with it, the chance to fully understand its nature. This is the final chance to analyze 3IATLAS before it slips beyond our reach forever. The eruptions witnessed from 3IATLAS in December 2025 were unlike anything we've seen from local comets. Instruments like SPHERICS recorded full-on eruptions, releasing volatile compounds like methanol, methane, and cyanide organic molecules that are often associated with life on Earth. This discovery raised immediate questions. Was 3IATLAS a potential incubator for life? Could the molecules it ejected be the remnants of a biologically active system? As 3IATLAS nears its closest approach to Jupiter, the solar flux from our Sun has become insufficient to maintain the eruptions that were so dramatic earlier. The object's insulating crust, formed over billions of years, has shielded it from the intense heat of the Sunday. This crust, hardened by cosmic radiation, has kept the object's core in a state of stasis until the heat from the Sun finally began to breach it. Once this happened, the chemical venting occurred, an eruption that released material from the object's interior into space. This eruption is highly significant. The ejected material contains elements from an alien star system, and it is now drifting through our solar system. What's fascinating is that we have the instruments necessary to analyze this material. The JUICE and Juno spacecraft will allow us to probe the object's surface, studying the very chemistry that formed it. The implications of this discovery go beyond simple chemistry. They suggest that 3IATLAS could hold the key to understanding the processes that led to the formation of life in distant star systems. One intriguing hypothesis is the seeding theory, which suggests that objects like 3IATLAS could have played a role in seeding life on planets in their wake. As the object erupts, it ejects rocky debris and organic material that could potentially be carried to other star systems. This idea aligns with theories about panspermia, which propose that life may have originated from microorganisms carried on comets or asteroids. If 3IATLAS has indeed ejected material containing the building blocks of life, this could provide the first direct evidence supporting the seeding hypothesis. One of the most intriguing aspects of 3IATLAS is its orbital trajectory. With an eccentricity of 6.14, the object's path is highly irregular and almost straight line in appearance, suggesting it barely acknowledges the gravitational influence of our Sunday. For comparison, the famous interstellar object Oumuamua had an eccentricity of just 1.2. 3IATLAS is moving so quickly that it appears to be barely influenced by the Sun's gravity. It arrived at our solar system traveling at twice the speed of Earth, and it has maintained that velocity as it continues on its path. What makes this even more remarkable is the object's chemistry. Based on its high carbon dioxide ratios and the presence of nickel vapor without iron, it's clear that 3IATLAS is not a typical comet from our solar system. It's a fragment of a different star system, one that formed under conditions vastly different from our own. This object carries with it a chemical fingerprint that offers a snapshot of a world far removed from anything we've studied before. The anomaly doesn't end there. Data from the Parkes Observatory in Australia, which should have provided crucial information on the object's chemical activity, remains unpublished. Despite findings from other observatories like the Allen Telescope Array and Greenbank, the data from Parkes remains hidden. This raises questions about what might be in the data and what is being withheld from the public. As 3IATLAS accelerates toward the outer reaches of the solar system, these unanswered questions continue to haunt scientists and researchers alike. We are now in the final countdown. In just a matter of days, 3IATLAS will pass through the Jovian system on its way out of the solar system. This will be the last time we have the opportunity to study this interstellar traveler in detail. After March 18, 2026, 3IATLAS will continue its journey into the Oort cloud, a region of space so cold that temperatures drop to absolute zero. There will be no follow-up mission, no second chance to study this object. Once it is gone, it will be lost to us forever. As we approach this final encounter, we are left with the tantalizing question: what have the spectrometers already discovered that we are not yet ready to hear? Recent data has already challenged our understanding of orbital mechanics, showing that 3IATLAS is not simply drifting through space but actively navigating its path with a precision that defies conventional explanations. The evidence suggests that this object is moving with purpose, possibly even with intent. The questions surrounding 3IATLAS are profound. What is the true nature of its trajectory? What secrets does it hold about the formation of stars, planets, and perhaps life itself? As we prepare for the final encounter, we must brace ourselves for the possibility that the answers to these questions will alter the way we understand the universe. This is a moment in history, an opportunity that may never come again. Stay tuned for further updates as we continue to unravel the mysteries of 3IATLAS. Don't forget to like, subscribe, and turn on notifications so you don't miss any of the latest revelations. The clock is ticking, and the final chapter of this cosmic story is about to be written.